Have you ever wondered how the mobile cell services of India are operating? Well, we of Team 39 are here to tell you. I'm Amisetti,
I'm Pranav Cycle and System.
Satish Kumpatla.
I'm Lakul Gupta.
and we're here to tell you about our study of the patterns in the cell services of India. First, our project overview. We study the various cell signal strength and speeds for various service providers across India. We've used this following technology: Jupyter Notebook, NumPy, Pandas, and Seaborn. The six attributes in the dataset that we have chosen are network providers, download or upload, technology which is 4G or 3G, signal strength, data speed, and area orientation. One of the first processes that we've chosen in analyzing and cleaning our data is the first preliminary data cleaning process where we fix any missing values in the respective attributes. Following that, we've applied some well-known pre-processing techniques such as data reduction, which involves aggregation, and data transformation involving normalization and feature creation. Now coming to the main data mining techniques that we have used after the pre-processing, which involve DB-scan clustering, fuzzy C-means clustering, outlier analysis using z-scores for outlier detection, Hopkins statistics, cluster stability, elbow method. Now first, we're coming to outlier analysis. We've used z-score outlier detection since we found it was the best way to find the unusualness in the data set over. You can see how far away certain values are spread away from the mean. Set a threshold of z-scores greater than 3 or minus 3. And we working with these threshold levels across the speed values and strength values, we found that there are only outliers in speed values. 98% of outliers are geo. And these outliers only exist for values of greater than 3. And the total outlier percentage is only slightly above 6% out of the total data set. Now, from this in front of the talking about.
Yes, hello. So the part of the project which I worked on was implementing fuzzy C means, and the purpose of implementing fuzzy C means arose after the implementation of DBScan was done. Now, in our case, we are going to be the reason why we tried to implement fuzzy C means was to see whether the data could fit into two of the following clusters, whether it was part of the set of 4G entries or whether it was part of the set of 3G entries. So once the clustering was done, the clustering was done in the first place because of the inaccuracy of DBScan clustering. We noticed that many of the points were not being classified properly, and we turned to fuzzy C-means to get an idea of whether they could be weighted by a decent amount. However, unfortunately, upon running fuzzy C-means on the data set, it turned out that most of the records were present equally within both clusters. That both of them had a membership value of 0.5 for each cluster. So unfortunately, we did not get anywhere with fuzzy C-means. Now on to DBScan. So prior to studying DBScan, we looked at Hopkins statistic, and we used this technique to figure out whether a certain subgroup of data was clusterable. What do we mean by a subgroup of data? A subgroup of data was taken by fixing certain attributes and considering all the data entries which were falling under those attributes. So, for example, we fixed the service provider, we fixed the technology, the area, the year, the month, etc. And according to Hopkins statistic, if the value is close to 1, that means the data is highly clusterable. If it's near to 0.5, that means the data is random. And if it's close to 0, that means it is uniform. Now, Satish will go on to explain how DBScan was implemented and what we did throughout the algorithm. Satish?
Hello, I am Satish Kumpatla. I had performed an analysis on the dataset using the DBScan clustering. Basically, DBScan is used for finding the dense regions in the dataset. For our dataset consists of so many points that are close to each other, so that they got formed very dense regions in our dataset. So it's a good idea to implement DBScan for our dataset. We can clearly observe the noise points in the dataset after performing the DBScan algorithm. It gives a clear idea of how many noise points are distributed in the dataset. The main advantage of DBScan compared to the other clustering algorithms, example k-means, is there is no need to define the number of clusters in the DBScan, and it's very high resistance to noise, and it removes the noise points very well compared to other algorithms. The parameters that are required for DBScan are epsilon and min points, which are found by plotting the graph between kth nearest neighbor and the distance sorted according to the kth nearest neighbor, and followed by Nakul Gupta.
Hello, it's Nakul Gupta. So we did cluster stabilization using ELBO method. In ELBO method, we plot distortion value. We plot distortion value and visualize the bend and in the plot. At the bend, so we can easily see if we increase or decrease the number of clusters, distortion value will either increase too much or either decrease very less. So by that, if we so we can choose appropriate number of clusters in the sharp change of the plot as per requirement of our data.